want to answer Renee's question better, which is, what's the minimum? Brandon, would you mind turning the lights back on? Thank you, Fran. So, one of the things that 244 or 243 students often balk at is when they look at a study that I bring to class. The first time you guys balked, I remember it last term, I showed you a Gallup poll on Americans' approval or disapproval of drilling in Anwar, or just drilling, offshore oil drilling in general. It was one of the first things I showed you in class. And I said, anything concern you about this? And every single class I've ever showed that to goes, there's only 1,012 in the sample. I said, oh, that's fine. They're like, how can that be fine? How can 1,012 be enough to be fine? Well, the answer is totally fine. It's almost, I would like a little bit more. But here's the deal. Here's the deal. How to pick a sample size. And this, there's a couple different ways to do it. I'm going to caveat this with how to pick a sample size when studying proportions. You have to kind of adjust how you pick your sample size because the mathematics changes whether you're studying proportions or averages. And you'll see more of that later on today or on whenever I see you guys next. I guess I'll see you again on Wednesday. Okay. So how do you pick a sample size? Well, here's the deal. Here's the deal. You can't just pull out of thin air. You can't just pull out of thin air. If you pull it out of thin air, then you can't justify why it works. So here's what you have to ask yourself two questions. Ask two questions. Can you think of what one of those questions might be? After you've decided what you're going to study, what might one of those questions be, Kate?
How confident you will be?
That's an awesome question to ask. First question, how confident do you want to be? How confident do you want to be? First of all, ask that question always. Always, 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 always. Yes, thank you! The next question is, how precise do you want to be? Now, when Lauren says precision, what does she mean? That's a great way to say it. Thank you, Skylar!
Small one. You want a smaller rectangle as opposed to...
Let me come back to that. That's okay. Lauren, I love what she just said. She said you want a smaller one versus a larger one. We can decide based on a lot of variables that are outside the scope of mathematics. Let's come back to that. I love that. I love that. So basically, at this point, determine your maximum margin of error that you will allow for. This ties into what Skylar and Lauren just said. So pick how off are you willing to be with your estimate? Plus or minus what? Determine. Let's make it a question. How off can we be in precision? And we say, how off can we be in precision? What I mean by that is, what's your maximum allowable margin of error? Will you accept 4%? Will you accept 3%? Can you accept 2%? Can you be off by no more than 1%? These are the questions you have to ask. Generally, 3% is a fairly good estimate in the news, I've noticed. Although that might not be good enough for, say, a drug study. Okay? So, first, how confident do you want to be? You have to know that first. Secondly, how off will you allow yourself to be? So, those are the two questions. You guys nailed it. Those are the two questions you have to ask. Thank you, thank you, thank you. Now, mathematically, how can we figure that out? How are these related in what we've been talking about over the past couple days? How are these related? We had a report. It's still on the board. Yeah, look at that. Do you see? Confident. Margin of error. Look. Margin of error. Confidence. That's tied to the confidence, right? I'm sorry. For those of you watching the home game, I'm pointing to the margin of error formula. I'll write it again on the board. Apologies. There's a confidence measure. There's a margin of error measure. Here's a sample size. Hot damn! I think we got it. We know what the margin of error formula already is by definition of standard error binomial. It's going to be some multiplier z, which is determined by our confidence, times the radical of P hat Q hat over N. Now if you look at that, how many variables are in that bad boy?
4x.
But actually, I like that answer. Technically speaking, there are only 4. Because P and Q, since they add to 1, if you know this one is not a variable anymore. So that's a good answer. But we can say 4 or 5. 3 of them are going to be unknown going into this argument. For example, you're looking for sample size, yes? You're trying to decide what your sample size is. You're trying to decide what N is. That's going to be an unknown. You have to pick these 2 things. Now, I'm going to do this really quickly. If you want more of a mathematical breakdown as to why what I'm about to write is true, I encourage you to look at the schedule page, or not schedule page, look at your homework sheet. I've got a mathematical video explaining how to get from here down to this. What's it going to be? It's going to be those are the same equation. Those are the same equation. If you want to see the intermediate steps, I've got a video you can check out. And I'm not driving you to that because I have like ads on it or anything. It's just sitting there waiting for you guys if you want to see more mathematics. If you get from one to the other. Okay? I've learned not to do that in class because it makes people drag me.
You want to turn out, why is it? Never mind, I'll let you finish.
That's okay. That's totally fine. Yes, the idea is you have to invert these guys because it's proportion. That's why margin of error is now on the bottom and N is now on the top. Just
You're still trying to figure out your sample.
yes, and that's why I wanted to get N on one side by itself. Then
Okay, so you're okay.
I wanted to get N over here by itself because I'm trying to pick a sample size. So I wanted to get N isolated. Mathematics, friends, guys, I've got the video. I've got it slowed down nicely. 5-10 minutes of explanation. Now I'm happier than I was before, and here's why. I've got N on one side by itself, yay. I've got this guy, which is a measure of what? Remember what he's a measure of? He's a measure of confidence, Stacy. So that answers Kate's question.
Is that your variance or something? Your deviation squared?
That's this guy, margin of error squared. Yep. And this was your concern, right, Martin? Your concern was pick a precision.
Right.
There's your precision. Straight scale, there's your margin of error, your precision. Good, good. Real quick, I'm going to pick one math note. You see why they're squared? You had to get rid of the square root.
Right.
So everything had to be squared, except it was on, okay, good, good. If you want more, like I said, videos are waiting for you. Here's what drives me nuts, though.
Yeah.
I don't like that at all, huh? Because what's the problem?
You don't have that information.
You don't have that information. The whole point of this study is to get that. But here we are stuck. It's a chicken-egg thing, right? I want to know p hat. But I have to know p hat to figure out what to know to get p hat. Chicken, egg, chicken, egg, chicken, egg. So what do we do mathematically? Say that again.
Is
Yeah.
there a formula we're using?
Well, no, this is the formula.
Like a,
Oh, actually, I wrote you a program for this. Yes, I did. And you'll have it. It's sitting in your calculators already. But hold tight. Before we go to that, I want to make sure you understand what the hell it's doing. Remember how, for different values of P and Q, this product was different? For example, when P was 0.1, Q would have to be 0.9, so the product was 0.09. And if P was 0.2, Q would be 0.8, the 0.16 product. If this was 0.3, 0.7, 0.21 product. As this gets bigger, what's going to happen to this? Votes. As this gets bigger, this is going to get bigger, yeah? So, I think it makes sense if to ensure ourselves the best possible study, to make this as big as possible. Because that's going to ensure we have as large a sample as possible to maintain our confidence in our margin of error. My question to you, to make this as big as possible, what should these be? I have a vote for 0.5. Skylar says yes, I like that 0.5 and 0.5. Megan says yes. Can you prove why it's 0.5 and 0.5?
Try anything else.
Try. That's a damn good answer, Michael. Try anything else. If you want a proof, there's a video that pairs with the first video I told you about that explains why you want to make these both 0.5. Mathematically, it has to do with a parabola. It has to do with the parabola, the vertex of a parabola opening upside down. If you care, you might not care, that's okay too. But in order to make this as large as possible, make each of these equal to a half. That will make their product as large as possible. It makes the standard deviation as large as possible, which will make your sample size as large as possible while maintaining these two pieces here. So we're going to let this guy equal to 0.5 and let this guy equal to 0.5. Multiplied together makes 0.25, which we remember, we heard that earlier today, didn't we? 0.25. Somewhere earlier today we had that 0.25 come up. So we now have a beautiful little formula for calculating sample size, don't we? You simply take the product of 0.25, 1/4, times whatever your confidence critical value is, z squared, and that's a z, and divide it by your margin of error squared. Boom! That's it. That tells you how large of a sample you need. If you pick your confidence and you pick your margin of error. Now here's the beauty. Some of you might feel a little squeamish about the fact that I just let these equal 0.5. Some of you might say, well, Sean, what if it's not? Renee's saying, I'm not feeling squeamish at all. Good for you, sister. If you are, it's okay. Because we're assuming that P and Q are both 0.5. If they're not 0.5, suppose they're further away from 0.5, you would actually need a smaller sample in order to capture them more effectively with 95% confidence in whatever margin of error that you want. Mathematically, you need a smaller sample because this product would be smaller, yes? But if you draw a larger sample, isn't that just going to be better because you have more data? So what you've done here is a worst case scenario sample size. The worst case scenario is that the proportion is half and half. Half and half. You're going to need more data to make sure that it's half and half. If it's not half and half, you're going to see the results much quicker. But with more data, you're just going to get them more precise. And that's why I used them. My goodness, you okay? It's okay, it's okay. I feel terrible here. Remember when I called this the maximum allowable margin of error? When you pick a maximum allowable, it doesn't mean that you're going to get that. You might get less, depending on what comes back for P hat and Q hat. But you won't get any more than that. You might actually get less. See what I'm getting at? Basically, this is disaster scenario. What's the absolute worst I can allow myself to do? I might do better. I might do better. Stace, what's the matter? What's the matter?
Just looking at this problem, trying to figure out.
Oh, good. Well, you've got the tool now. Let's figure it out. Let's figure it out. Let's pause the camera. Come back over here. Do it a couple different ways here. Here we go. Here we go.